Hi, and welcome to the Corbettmaths video solutions to the parallel lines practice questions. In this video, we're going to go through the video solutions to the practice questions for parallel lines. If you do want any extra help on parallel lines, if you go to video 196 on corbettmaths.com/content, that's the video tutorial on parallel lines. Alternatively, you could scan the QR code on the front of this booklet and that'll bring you straight to the video tutorial on parallel lines. Okay, so let's get started. So question number one. Okay, let's get started. So let's have a look at question number one. So question number one says, write down the gradient of a line that is parallel to y equals 7x plus 4. So this straight line is in the form y equals mx plus c. And that's the equation of a straight line where m is the gradient of the line and c is the y-intercept where it crosses the y-axis. Now the line that we've been given is y equals 7x plus 4. That means that this line has got a gradient of 7 and it crosses the y-axis at 4. Now for two lines to be parallel, they must have the same gradients, and we've been asked to write down the gradient of a line that's parallel to this line. So if it's parallel to this line, it must have the same gradient as this line. So the gradient of this line is 7, so the gradient of a line that's parallel to it would also be 7. Okay, let's have a look at question number 2. So let's have a look at question number 2. So question number 2 says, circle the equation of a line that's parallel to y equals 3x minus 5. So the gradient of this line is 3, because we've got a 3 in front of the x, so the gradient of this line is 3, so we're looking for another line that's got a gradient of 3 also. So the first line, we've got y equals 2x minus 5, the gradient of that line's 2, so that's not 3. Okay, our next line is y equals minus 3x plus 4, so the gradient of this line is minus 3 or negative 3. And our last line is y equals 3x plus 1, and the gradient of this line is 3. So those two lines are parallel, so we've been asked to circle the equation of a line parallel to y equals 3x minus 5, because the gradient of this line is 3 and the gradient of this line is 3, they're parallel, so we're going to circle this equation, y equals 3x plus 1. Okay, question 3. Question 3 says, write down the equation of a line that's parallel to y equals 2x minus 3. So we can write down the equation of any line that's parallel to it. So as long as the gradient's the same, it's going to be parallel to it. So we could write y equals 2x plus 1. We could write y equals 2x minus 8. We could even just write y equals 2x. All those lines would be parallel to y equals 2x minus 3. And you just need to write one of them down. So as long as it's y equals 2x and then something, and I would avoid using negative 3 because you want another line that's parallel to it, not the same line. So you need to write something else. So y equals 2x plus 1 or y equals 2x minus 8 or y equals 2x or something like that. Okay, let's have a look at question number 4. Okay, let's have a look at question number 4. So question number 4 says, write down the equation of a line that's parallel to y equals 6x plus 1 and passes through the point 0, 8. So we're looking for a line that's parallel to this line, y equals 6x plus 1, and it's in the form of y equals mx plus c. So the gradient of the line that we've been given is 6. So the line that we're looking for will also have a gradient of 6. So we're going to start off with y equals 6x. Now, the plus c stands for where it crosses the y-axis. So this line that we've been given is y equals 6x plus 1. So that goes through the coordinate 0, 1. It crosses the y-axis at 1. And the line that we're trying to find the equation of passes through the point 0, 8. So that's 8 on the y-axis. So that means that we're just going to then write plus 8. So it's y equals 6x plus 8. Y equals 6x plus 8. Because that line has got a gradient of 6. So it's parallel to the line that we were given. And it also passes through the point 0, 8. It passes through 8 on the y-axis. So it's plus 8. That's it. Okay, let's have a look at question number 5. Question number 5 says, write down the equation of a line that's parallel to y equals x plus 1 and passes through the point 0 minus 3. So let's start off by finding the gradient of the line we've been given. So the equation of a line is y equals mx plus c, and the number in front of x is the gradient. So here we've got y equals x plus 1. Now x is the same as 1x, so the gradient of the line we've been given is 1 because there will be a 1 here. So that means that the line that we're looking for will also have a gradient of 1. So we're going to write y equals, now we're not going to write 1x, we're going to write x, so it's going to be y equals x. So we've got the start of the equation, we've got y equals x. Now we need to find the plus c part, in other words, where the line will cross the y-axis. Now the line we're looking for passes through the point 0 minus 3. And that is, if we consider the point 0 minus 3, so x and y, 0 minus 3 would be here. So it crosses the y-axis at negative 3. So our line would look something like that. So it passes through negative 3, it's got a gradient of 1. So our equation would be y equals x, or 1x, x. And then our plus c where it crosses the y-axis will be negative 3. So the equation of the line we're looking for is y equals x minus 3, because that line is parallel to the one we've been given. It's got the same gradient, and it passes through the point 0 minus 3 on the y-axis. Okay, let's have a look at question number 6. Okay, let's have a look at question number 6. So question number 6 says, write down the equation of a line that's parallel to y equals minus 4x minus 5 and passes through the point 0, 10. So the line we've been given has got a gradient of negative 4 minus 4. So that means that our line, because it's parallel, will be y equals minus 4x. That'll be the start of it, the y equals mx. Now we need to find the plus c, in other words, the y-intercept. Now the line passes through the point 0, 10. So we know that the line passes through 0, 10. So it passes through 10 on the y-axis. So that means that our equation will be y equals minus 4x plus 10. And that's it. Okay, let's have a look at question number 7. So question number 7. Question number 7 says circle the equation of a line that's parallel to y equals minus x plus 2. Now this line has got a gradient of minus 1. Because it's minus x, that's the same as minus 1x. So the gradient of this line will be minus 1. M equals minus 1. The gradient's minus 1. So we're looking for a line that's parallel to that. So we're looking for a line that also has a gradient of minus 1. So y equals x plus 3. The gradient of that line is 1. Y equals minus x minus 1. The gradient of this line is minus 1. So that's going to be the line that's parallel to it, because it's got the same gradient, minus 1. And then here we've got y equals minus 2x minus 1. The gradient of this line is minus 2, so that line wouldn't be parallel. And that's it. Okay, let's have a look at question number 8. So question number 8 says circle the equation of a line that's parallel to y equals a quarter x. So this line has got a gradient of a quarter. So we're looking for a line that's parallel to it. So we're looking for another line that's got a gradient of a quarter. So let's have a look. Y equals a quarter x plus 2. Well, that line's got a gradient of a quarter, so that's going to be a line that's parallel to it. Let's just check there's no other lines that are parallel to it. Y equals minus 4x. No, the gradient of that line's minus 4. Y equals 4x. No, the gradient of that line's 4. And y equals minus a quarter x. So the gradient of that line's minus a quarter, so no, they're not parallel. So the line that's parallel to y equals a quarter x would be y equals a quarter x plus 2. Okay, let's have a look at question number 9. So question number 9 says lines A and B are parallel to each other. And line A passes through the point 0, 8. And line B has an equation y equals 3x plus 1. And we're told that they're parallel to each other, so that means that this line A will have the same gradient. And we've been asked to write down the equation of the line A. So let's write down the equation of this line A. So we know it's got the same gradient, so it's going to be y equals 3x because it's got the same gradient as the other line. And the gradient was 3, so our line's y equals 3x because it's got a gradient of 3. Now we need to find the plus c part where it crosses the y-axis. And this line A crosses the y-axis at 8, so our y-intercept will be 8. So our equation would be y equals 3x plus 8. And that's it. Okay, let's have a look at question number 10. Right, so let's have a look at question number 10. So question number 10 says the line A is shown below. So we've got the x and y axis and we've got the line A. And we've been asked to write down the gradient of the line A. So we need to find the gradient of this line. Now, there's a few different ways we can do that. We can, first of all, we can use the formula, which is the gradient m is equal to rise over run, or some people call it y2 minus y1 over x2 minus x1, but I just like using rise over run at GCSE level, like so. And to use this formula, rise over run, we need to choose 2 points on the line. So let's choose this point, the point 1, 7, so that's the point 1, 7. And let's choose another point. I'm going to choose this point here, which is equal to minus 1, 1. And what we're going to do is we're going to make a little triangle like so, or a little right angle triangle. And we're going to write down the run, so in other words, how much we've gone across. So we'll go from minus 1 to 1, so that run is 2. We're going 2 across. And the rise, well, we're going from here, we're going up 1, 2, 3, 4, 5, 6. So the rise would be 6 because we're going from a height of 1 up to a height of 7. So here we've got a rise of 6. And we've got a run of 2, and we're going to do 6 divided by 2, and 6 divided by 2 is 3. So the gradient of this line A is 3. So that's one way we can work out the gradient. Another way we can work out the gradient would have been, to look at the line, to find a point on the line. So let's choose this point, which is 0, 4, and to go 1 unit across. So we're going to go across 1 unit. Now here 1 unit is 1 square. Sometimes squares, the scale is different. So instead of going 1, 2, 3, 4, it might be 2, 4, 6, 8, and so on. Then you'd have to go 1 unit across, so halfway and so on. But here, if we go 1 across, so 1 across, we go up 3. So that means that the gradient is 3 because the gradient means for every 1 you go across, how much the line goes up by or down by. So the gradient of this line would be 3. So part A says write down the gradient of the line A, 3. And then part B says write down the equation of a line that's parallel to the line A. So the line A has the gradient 3. So we know that our line will be y equals 3x because it will be parallel to it. Now this line A is y equals, if we go back up and look at it, it's y equals 3x plus 4 because it passes through 4 on the y-axis. So we're just going to choose another line. So we could choose y equals 3x. We could just leave it as that. We could write y equals 3x plus 8, y equals 3x minus 20, and so on. So as long as the line is parallel, in other words, it has that 3x part, y equals 3x, and it's not plus 4 because you wouldn't just write down the same line. Okay, let's have a look at our next question. Okay, let's have a look at question number 11. So question number 11 says the straight line L passes through the point 0, 6 and 4 minus 2. And the straight line M passes through the point 0, 1 and is parallel to the line L. That's good, so these two lines are parallel. And we've been asked to find the equation of the line M. So M's a straight line, so we know it's going to be in the form y equals mx plus c. So we need to find the M, the gradient, and c, the y-intercept. Now it passes through the point 0, 1. That is the point, if we had the x and y axis, the point 0, 1. So that means that it passes through 1 on the y axis. So our equation for the line m, will be y equals mx plus 1, because it passes through 1 on the y axis. Now, in terms of m, we're going to need to find its gradient, and we know that it's parallel to the line L. So if we find the gradient of the line that passes through the point 0, 6 and 4 minus 2, well, because they're parallel, that would be the same as the gradient for the line m, so that means that we can find our equation because we know the value for m. So let's find the gradient of the line that passes through 0, 6 and 4, negative 2. So if we had the point 0, 6, so if we had an x and y axis, let's just do a little sketch here. So we'd have an x-axis and a y-axis, and 0, 6, well, 0, 6 would be up here somewhere, and I'm just going to change color ink, so I'm just going to change to blue. So the point 0, 6 would be up here somewhere, so 0, 6. And the point 4, negative 2, well, that'd be 4 across 2 down, so it'd be down there somewhere, 4, negative 2. So let's just sketch the line passing through those points. So like so. Now to find the gradient, we're going to use rise over run, and we can do that by doing our little triangle, so going across and down and making our right angle triangle. So we need to find the run and the rise. So here the run. So we're going to cross from 0 to 4. We're going from 0 across to 4. So the run would be 4. In terms of the rise, this line's going downwards, so it's not going to have a positive rise. It's actually going to have a negative rise because it's going downwards. And the height changes from 6 and it goes down to negative 2. So the height here, it's going from 6, goes down to 0 and then on down to negative 2. So it's going down by 8. So the rise would be negative 8 because it's going from 6 down to negative 2. So here we've got a run of 4 and a rise of negative 8 because the line's going downwards. So we'd write m, the gradient, is equal to rise over run. The rise is negative 8 and the run is 4 because we've gone 4 across, and negative 8 divided by 4, minus 8 divided by 4 is minus 2. So the gradient of this line is minus 2. Another way to consider that is that because the gradient is minus 2, it means that if we go across 1, it goes down 2, across 1, down 2, across 1, down 2, and across 1, down 2. And if you were at 0, 6, if you go across 1 and down 2, you'd be at 1, 4. Across 1 and down 2, you'd be at 2, 2. Across 1 and down 2, you'd be at 3, 0. And across 1 and down 2, you'd be at 4, minus 2. So now we know the gradient of the line L. That is the same as the gradient of the line M because they're parallel to each other. So we know the gradient of this line that we're looking for is minus 2. So our equation would be y equals minus 2x plus 1. And that's it. So that's the equation of the line M. Okay, question 12. So question 12 says, write down the equation of a line that is parallel to x plus 2y equals 4 and that passes through the point 0, 5. Now this question is a bit different than the ones we've looked at so far because this line isn't in the form y equals mx plus c. So whenever you're given something like this where you've got x plus 2y equals a number, you'll want to rearrange it and make y the subject if you can. So let's rearrange this and make y the subject. We want y equals. So here we want to make y equals. So here we've got x plus 2y equals 4. So if I want to get y on its own, let's get rid of the x first of all. So I'm going to take away x from both sides. So if I do that, I would have on the left hand side, well, x take away x is 0, and so we'd just be left with 2y. And on the right hand side, we could write 4 minus x if we wanted to, so because it's 4 take away x, we could write 4 minus x. Alternatively, because I want it in the form y equals mx plus c, I tend to like to have the x at the front. So here, because I'm taking away x, is going to be minus x, and then I've got 4, which is positive 4, so then I'm going to write plus 4. So what I've done there is I've taken away x's from both sides, and instead of writing 4 minus x, I've written minus x plus 4. Okay, we want to get the y on its own, so we don't want this multiplied by 2, so let's divide by 2 and let's divide by 2. So we're going to divide the left hand side of the equation by 2 and the right hand side by 2, or just everything by 2. So 2y divided by 2 is just y, and on the right hand side we had minus x, but we're going to divide that by 2, well that's minus 1x, and if you divide that by 2 you'd have minus a half x, because half of minus 1 would be minus a half, and then we've got 4, and we're dividing that by 2, so that'll be plus 2. So that's the equation of the line that we've been given. So in the question we were given x plus 2y equals 4, and when you rearrange that you get y equals minus a half x plus 2. Now we're trying to find the equation of the line that's parallel to this. That means it's going to have the same gradient, and the gradient of this line is minus a half. So our line will be y equals minus a half x, that's the start of our equation, but we need the plus c bit where it crosses the y-axis. Now it passes through the point 0, 5, so that's going to be 5 on the y-axis, so our y-intercept is 5. So the equation of the line that we're looking for is y equals minus a half x plus 5. So that's it. So this question was just a bit different because we needed to make y the subject to find its gradient nice and easily. Okay, question number 13. So question number 13 says the equation of 5 lines are given below. So we've got 5 lines. We've got line A, which is y equals 2x plus 3. Line B, which is y equals a half x minus 3. Then we've got y equals 6 minus x. Then we've got line D, which is y minus 2x equals 7. And finally line E, which is y plus 2x equals 3. And the first question says, which line passes through the point 1, 9? So in other words, the point that has an x coordinate of 1 and a y coordinate of 9. Now there's a couple of different ways we can do this. One is we can substitute x equals 1 and y equals 9 to each one of these equations and see which one works out to be the correct one. Or another way could be to substitute x equals 1 and see if we get y equals 9 for it. And that's the approach I'm going to do. I'm going to substitute x equals 1 into each of these and see what the y coordinate would be. So let's do that. So the first one I've got y equals and then 2 times x, so 2 times 1 is 2 plus 3, well you'd end up with 2 plus 3, so that'd be y equals 5. Well that's not 9, so it's not going to be line A. Line B, well y equals a half of x, well a half of 1 would be 0.5 or a half, and then take away 3. Well a half take away 3 would be minus 2.5, that's not 9, so it's not line B. Line C, we've got y equals 6 minus x, and x is 1, so 6 minus 1. 6 minus 1 is 5, so y equals 5. That's not 9, so no. Line D, we've got y subtract 2 times x, so 2 times 1 is 2, so y minus 2 equals 7. Well, we want to find y, so let's add 2 to both sides here, so add 2 and add 2 will give us y equals 9. So that line D goes through the points 1, 9 because we know that whenever x equals 1, y equals 9. So line D works, and let's just check that by checking line E. So let's substitute 1 into here, so you'd have y plus and then 2 times x, 2 times 1 is 2 equals 3. Taking away 2 from both sides gives us y equals 1. That's not 9. Which line passes through the point 1, 9? It would be line D. Okay, part B. So part B says which two lines cross the y-axis at the same point. So we're trying to find which two lines will cross the y-axis at the same point. In other words, which two lines will have the same y-intercept. So if we can get them all into the form y equals mx plus c, we can see that y-intercept really easily. So let's have a look and see where they cross. So our first line, line A, the equation is y equals 2x plus 3. So this line has a y-intercept of 0, 3 because it passes through 3 on the y-axis. Our next line, it's in the form y equals mx plus c. So it has a y-intercept of minus 3, so it passes through the point 0, minus 3. So they don't pass through at the same point. Our next line, line C, it's y equals 6 minus x. Now that would be the same as y equals minus x plus 6, just moving the minus x to the front, and then it's positive 6, so plus 6. So that crosses through 6 in the y-axis, so that would have a y-intercept of 0, 6. So none of these pass through the y-axis at the same point yet. Line D is not in the form y equals mx plus c, so I'm just going to rub this out. And line D is not in the form y equals mx plus c, so let's make it in the form y equals mx plus c. So we've got y minus 2x equals 7. We want the y on its own, so let's add 2x to both sides, so add 2x and add 2x. We add 2x to get rid of the minus 2x, so we'll just be left with y on the left hand side, and on the right hand side we've got 7 plus 2x. Let's put the 2x at the front, so that'll be 2x plus 7. So this line, y equals 2x plus 7, is the line D, and it crosses the y-axis at 7, so that means that its y-intercept will be the point 0, 7. And finally, line E, hopefully it'll be one of these 4 points. We've got y plus 2x equals 3. We want to make y the subject, so let's take away 2x and take away 2x. So it'll be y equals, and then on the right hand side we've got 3 minus 2x. Let's put the minus 2x at the front, so minus 2x. Now the 3 was positive, so it'll be plus 3. So it crosses the y-axis at 3, so that'll be the point 0, 3. So that's great. Line A and line E both pass through the point 0, 3. So that means they both pass through the same point on the y-axis. So that would be A and E. And part C says which two lines are parallel. So we're looking for two lines with the same gradient, and that's great because we've already got them all in the form y equals mx plus c. So the gradient of the first line, well, let's just get rid of this a minute. The gradient of the first line is 2, so m equals 2. Line B, the gradient would be a half, m equals a half. The gradient of the line C, well, we had y equals minus x plus 6, that's minus 1x, so that's going to be m equals minus 1. D, the line D, we were given y equals minus 2x equals 7. Now we rearrange that to get y equals 2x plus 7. The gradient of this line would be 2, so m equals 2. That's great. Line A and D have got the same gradient. Let's just check line E doesn't have as any of the others. So line E, the gradient of this line, we had y equals minus 2x plus 3. The gradient would be minus 2, so m equals minus 2. So the lines A and D would be parallel because they've got the same gradient. So A and D. That's it. Okay, let's have a look at question number 14. So question number 14 says a straight line A passes through the point, let's have a look at this, 2, 0 and 5, 6. So 2, 0 and 5, 6. That's great. So that's the line A. And we've been asked in the question to work out the gradient of the line A. So let's make our triangle. We've got 2 points on the line, so let's use those to make our little triangle. So we'll do our rise over run to get our gradient. So there's our little right angle triangle. The run, well, we're going from 2 to 5, so the run will be 3. And the rise, well, we're going up from 0 all the way up to 6, so the rise would be 6. Let's just check that. 1, 2, 3, 4, 5, 6. So 6. Now we want to find the gradient, so that's going to be rise divided by run. So the rise is 6 divided by the run, which is 3, and 6 divided by 3 is 2. And let's just check that, because remember, the gradient is for every 1 unit you move across, how many the line goes up or down by. So because we've got a gradient of 2, it should be that if we go across 1, we go up 2. Across 1, up 2, and let's just check. So let's start off with this point. Across 1, so from 2 to 3 is 1, and up 1, 2, yep, that works. Across 1, up 2, yep, and so on. Okay, let's have a look at our next question. So part A says work out the gradient of the line A, that is 2. Okay, and the next part says line B is parallel to line A and it passes through the point 1, 4. So let's have a look and see what we've got here. So we've got our line A, so this line. We've got line B, which is parallel to it and passes through the point 1, 4, and that's been plotted on the graph for us. So there's 2 different ways which we can do this. One approach is to take your ruler, draw a line that's parallel to it and see where it crosses the y-axis, and that would be one way to do it. Actually, I can actually think of 2 different ways. So I'm actually going to use that approach to begin with. So I've just drawn a line that's parallel to the line A, so they're parallel, and it passes through the point 1, 4. So that is the line B. And if we want to find the equation of this line, we know it's in the form y equals mx plus c. Now we know the gradient is 2, so that's going to be y equals 2x, and we just need to find the plus c where it crosses the y-axis. And if we look at our line, it crosses the y-axis at 2, so it'll be y equals 2x plus 2. So that would be the equation of that line. So it'd be y equals 2x plus 2. So that's one way we can find the equation of the line B. Now there's a couple of different ways that we can do it. One approach would be, rather than draw the line, so rather than drawing that line, what we could have done was, well, we already knew that the gradient of the line A was 2, so we knew, because this was parallel, it was going to be y equals 2x. And then we knew it passed through the point 1, 4. Now using our knowledge of gradient, we knew the gradient of the line A was 2, and that meant for every 1 we go across, we go up 2. And that would be the same for the line B because they're parallel. Now if we're going backwards, that means that for every 1 we go across, we're going to go down 2, so 1, 2. So it would have to pass through this point here, so the point 0, 2. So that means that our line would be y equals 2x plus 2. So that's the second way we could have found the equation of that line. And there's also a third way, and I'm just going to show you that now. So a third way would have been, now because we know the gradient of the line A was 2, we knew that the equation of the line B would have to start off with y equals 2x, and then there would be a certain number after a plus c that we're trying to find. So we'd write down y equals 2x plus c. Now, but we know that it passes through the point 1, 4. So we could look at our point 1, 4 and we would say, well, the x coordinate is 1 because along the corridor x, and then up the stairs the y then would be next, so our y coordinate would be 4. And we could substitute in x equals 1 and y equals 4 into this y equals 2x plus c, and that would help us find our plus c, and then we could then write down the equation. So this approach is really useful, particularly if you don't have a graph drawn for you, or if the point is really far away from the y-axis, or if you've maybe got decimals and so on. So let's have a look at this. So we've got y equals 2x plus c. We know that our x coordinate is 1 and our y coordinate is 4, so let's substitute in 4 for y. So we'd have 4 equals 2x, well x is 1, so that's 2 times 1, and 2 times 1 is 2, and then we've got plus c. Now we want to find c, so we're going to take away 2 from both sides of this equation, so take away 2 and take away 2. 4 take away 2 is 2, and then we took away 2 to get rid of this 2, so we'd just be left with c. So we've got 2 equals c, or c equals 2. So we've found our y-intercept of 2, so we'd write y equals, and instead of 2x plus c, we'd write 2x plus 2. So we'd write 2x plus 2. So there's 3 different ways in which we found that equation of line B. Okay, let's have a look at our next question. Okay, let's have a look at question number 15. So here's question 15, and we've got these set of axes, and we've got this line in red. So if we scroll down, we can see that it says line A is drawn on the grid, so this is line A, and another line B is parallel to line A and passes through the point 2, 0. So it's going to pass through this point here. And we've been asked to find the equation for line B. So line B, it's a straight line, so we're going to have y equals mx plus c. So we need to find the gradient and we need to find the y-intercept. So let's first of all find the gradient, because we know it's parallel to this line that's been given to us. So if we find the gradient of this line, then that will be the same as the gradient for the line we want. line B. So let's choose 2 points. So I'm going to choose this point, which is the point 0, 4, and I'm going to choose this point, which is the point 1, 0. And we're going to do our rise over run. So let's do our little right angle triangle. So we've got our triangle and the line's going downwards, so the rise will be negative. So first of all, let's find our run. Well, we're going from 0 across to 1, so that's going to be a run of 1. And in terms of our rise, well, we're going from a height of 4 down to a height of 0, so our rise will be negative 4. We're going down 4. So our gradient m is equal to the rise, that's going to be negative 4, divided by the run, that's 1, and negative 4 divided by 1 is negative 4, minus 4. So our gradient is minus 4. The gradient of this line is minus 4. So if we go down to our equation, we've got y equals mx plus c. So we now know our gradient, because it's parallel, it's going to be the same gradient of minus 4. So we've got y equals minus 4x plus c. Now we want to find this plus c where our parallel line passes the y-axis, or where it crosses the y-axis. So we could do it a few different ways. Because we know it passes through the point 2, 0, we could draw another line that is parallel to this red line and find where it crosses the y-axis, and that'll be our y-intercept, so that'll be our plus c. Alternatively, because we know our gradient is minus 4, we could go backwards. So we could go across 1, up 4, across 1, up 4, and then find where it crosses the y-axis. So I think that'll be 8 if we did that, across 1, up 4, across 1, up 4 to 8. Alternatively, we could use substitution and work it out that way, and that's what I'm actually going to do, because that's going to be quite useful for our later questions. So we've got our point, so we know the line passes through the point 2, 0, and because we know that we've got y equals minus 4x plus c, if we substitute x being 2 and y being 0 into that equation, we can find our c. So y, well, y is 0, so we're going to have 0 equals, then we've got minus 4 times x, well, x is 2, and minus 4 times 2 is minus 8, so that'll be minus 8, and then we've got our plus c. So we want c on its own, so let's get rid of the minus 8 on the right hand side, so let's add 8 to both sides, so add 8 and add 8, so that'll give us 8 on the left hand side, and on the right hand side we would just be left with c. So c equals 8, like I said. So we've got y equals minus 4x, and then we know that c is equal to 8, so we then write plus 8. That's it. So our equation for the line B is y equals minus 4x plus 8. Okay, let's have a look at our next question. So question number 16. Okay, let's have a look at question number 16. So in question number 16, we've got this graph and we've got a line drawn on it, and it says shown above is the graph of line L. So this is line L, and we're told that line M is parallel to line L and passes through the point 1, 6. Find the equation of the line M. So we're trying to find the equation of a line that's parallel to this line and passing through the point 1, 6. So let's plot our point 1, 6 on, so 1, 6. So it's going to pass through that point. So again, we're going to use a similar approach. We're going to find the gradient of the line we've been given. We then know that would be the same as the gradient for the line M that we're trying to find the equation of. And then we would just find where that crosses the y-axis, and that'll be our plus c. So first of all, let's find our gradient of this line. So let's choose 2 points. So let's choose 2 points, and the 2 points I'm going to choose are 0, 16 and 4, 0. So let's draw a right angle triangle. So we're going to go across to 4 and down to 0. So we've drawn our little right angle triangle. Now we want to find our run and our rise. So our run, well, we're going from 0 across to 4, so our run will be 4. And in terms of our rise, it's going downwards, so it's going to be a negative rise. And we're going from 16 down to 0, so our rise will be negative 16. In terms of gradient, the gradient is the rise over run. So the rise is minus 16, and the run is equal to 4. And minus 16 divided by 4 will be minus 4. So the gradient of this line, this red line, is minus 4. And again, we could check that. We could choose a point 16, and we could go across 1 and down 4, and we get to 12. Across 1 and down 4, and we get to 8, and so on. So we know the gradient's minus 4. So the gradient of the line we've been given is minus 4. And if we go down to our question again, the question said, the line M is parallel to this line, so it'll be in the form y equals mx plus c. It's a straight line, and it's parallel to this line, so it'll have the same gradient, y equals minus 4x plus c. So we've got y equals minus 4x plus c. So we want to find where our line M, crosses the y-axis, that y-intercept. Now I've been told a point, which is the point 1, 6, this point. So again, we could get our ruler and draw a parallel line and just see where it crosses the y-axis. Or we could use that approach where we know the gradient's equal to minus 4, so we can go across 1, up 4, and we'll see that that's 10. I like that approach, actually, it's quite nice. Or alternatively, we can call these x and y, substitute them in and find our c. And that's the approach I'm going to use because it's going to be quite useful for later on in the video. So let's do that. But I do like that approach of going across 1, back up 4 and seeing that it'll be 10. So we should hopefully get y equals minus 4x plus 10. And let's see if we do. So we've got x equals 1 and y equals 6. So let's substitute those in. So we're going to have 6 equals, then minus 4 times x, and x is 1. So minus 4 times 1 is minus 4 plus c. Now we want to find our c, so we want to get rid of this minus 4, so we're going to add 4 and add 4. 6 plus 4 is 10, which that's good, and then on the right hand side we've just left with c, so c equals 10, and that's it. So the equation of the line m would be y equals minus 4x plus 10, and that's it. Okay, let's have a look at our next question. So let's have a look at question 17. So question 17 says the line L is drawn on the grid. So this red line is the line L, and we've got this point P, and we'll see what the rest of the question says. And it says find the equation of L. So we're going to find the equation of this red line to begin with. So you want to find its gradient and its y-intercept, because it'll be in the form y equals mx plus c. So the gradient of this line, let's choose 2 points. So I'm going to choose the point 0, 6, and I'm going to choose the point 2, 0. So in terms of the gradient, we're going to go across and down, make our little right angle triangle. Let's find our run. Well, we're going from 0 across to 2, so our run will be 2. And our rise, we're going from 6 down to 0, so our rise will be negative 6 because we're going downwards. So then we would do minus 6 divided by 2 is equal to minus 3. So the gradient of this line is minus 3. So we'd have y equals minus 3x plus c. Let's just check that gradient. Let's choose a point. So here we've got minus 1, 9. If we go across 1, and down 3, we get to 6. That's great. So that has a gradient of minus 3. And now we want to find our plus c, so where it crosses the y-axis. Now it crosses the y-axis at the point 6, so it's going to be y equals minus 3x plus 6. So y equals minus 3x plus 6. And that's the equation of this line that we've been given, this red line, L. Now we've been told the point P has coordinates minus 2, 9. Find the equation of the line that is parallel to L, so it's parallel to this, so it'll have the same gradient of minus 3 and passes through the point P. So we could get a ruler and draw a nice parallel line through P and see where it crosses the y-axis, so that approach would work. Alternatively, we know the gradient's minus 3, so we could go across 1, down 3 to 6, across 1, down 3, and you should hopefully get to them 3. So our answer should be for this question y equals minus 3x plus 3. But I'm going to use the substitution approach again just because it might become useful later. So we're going to call this x, that's the x coordinate, and that's the y coordinate. So we know that x is minus 2 and y is 9 at that point P. And because it passes through that line, then we can substitute those into the equation. So we're going to have the equation y equals, now it's parallel to L, so it'll have the same gradient, minus 3x plus c. We want to find where it crosses the y-axis. And let's substitute those in and see what we get. So 9 is y, so we're going to have 9 equals minus 3 times x, which is minus 2. Now minus 3 times minus 2 is 6, so that'll be 6 plus c. And then if we take 6 away from both sides of this equation, we're going to have 3 equals c. And that's it, so c equals 3, which we wanted to get. So y equals minus 3x plus 3. And that's the equation of the line that's parallel to L and passing through the point P, which is minus 2, 9. Let's have a look at our next question. So question 18. Line A and line B are parallel. Line A has equation y equals 5x plus 9, and B passes through the point 7, 41. Find the equation of the line B. So this is similar to the previous questions, but we don't have the grid, so that substitution approach will hopefully be useful for this. So we're trying to find the equation of the line B. So it's going to be in the form y equals mx plus c. And we know the equation of the line that's parallel to, which is y equals 5x plus 9, and the gradient of this line would be 5, so that means the gradient of the line B would be 5, so we're going to have y equals 5x plus c. So we want to find this c, and that's where this line B, crosses the y-axis. Now we could do that in a couple of ways. We could use the fact that we know the gradient's 5 and go across 1 down, 5 across 1 down, 5 across 1 down, 5 and that 7 times, and hopefully get that answer of where it crosses the y-axis. But we might make a mistake as there's quite a few steps we need to make. Alternatively, we could just look at this coordinate and say the x coordinate's 7, the y coordinate's 41, and we could substitute those into the equation we've got so far to find our c. So y is 41, so we're going to have 41 equals 5 times x, and x is 7, so 5 times 7 is 35 plus c. And if we take 35 away from both sides, we'll then get that 41 take away 35 is 6. And on the right hand side, we're taking away 35 to get rid of the 35, so we're just left with c. So c equals 6. So in terms of the equation of the line B, we'd have y equals, its gradient is 5, so 5x, and it crosses the y-axis at 6, so plus 6. And that's it. Okay, let's have a look at question 19. So question 19 says a straight line L has equation y equals 3x plus 2, and the line M is parallel to that line and passes through the point 5 minus 1. Find the equation of the line M. So again, we want to find the equation of the line M, so it's going to be y equals mx plus c. We know a line that's parallel to it, so it'll have the same gradient of 3, so it's going to be y equals 3x plus c. And then if we look at our point that it passes through this point. So we know that if we substitute those points in, that x equals 5 and y equals -1 into here, we can find where the line M crosses the y-axis. So x equals 5 and y equals, and we substitute those in, we're going to have, well, we'll have -1 equals 3 times 5, so that's 15, plus c. And then if we take 15 away from both sides, we'd have, well, -1 take away 15 would be -16, and that equals c. So we get c equals -16. So this line M will cross the y-axis at -16, and it has a gradient of 3. So that means our answer would be y equals 3x minus 16. Okay, let's have a look at question number 20. So question number 20, write down the equation of the line that's parallel to y equals 8x minus 4 and passes through the point -3 minus 1. So because it's parallel to y equals 8x minus 4, it'll have the same gradient of 8. So we're going to have y equals 8x plus c. And we want to find c where it crosses the y-axis. Now if we have a look at our coordinates, we've got -3, -1. So x is -3 and y is -1. And let's substitute those in and see what we get. So we'd have -1 for y equals 8 times x, which is 8 times -3. Well, 8 times 3 is 24, so 8 times -3 would be -24. Plus c. Now we want to find c, so we want to get rid of this -24. So let's add 24 to both sides. So add 24 and add 24. -1 plus 24 would be 23. So you'd have 23 equals c. So c equals 23. So the question says write down the equation. So we know it's y equals, we know the gradient's 8, so it's 8x, and then we've got plus 23. And that's it. Okay, question 21. Okay, question number 21 says, show that the lines with equations y equals 4x minus 1 and 3y minus 12x plus 1 equals 0 are parallel. So if lines are parallel, they have the same gradient. So here we've got y equals 4x minus 1. So for this line, we've got the gradient equals 4 because we know that it's in the form y equals mx plus c. The number in front of the x is 4, so the gradient of that line is 4. Whereas this line, this 3y minus 12x plus 1 equals 0, it's not in the form y equals mx plus c. We want it in the form y equals mx plus c, and then we can look at the gradient and just find it straight away. So if we have 3y minus 12x plus 1 equals 0, we can rearrange this to make y the subject. So we want to get the y on its own. So let's first of all get rid of this minus 12x from the left hand side. So if we add 12x and add 12x, what would we get? So on the left hand side, we're adding 12x to get rid of the minus 12x, so we'd just be left with 3y, and then we've got plus 1. And on the right hand side, we'd have 12x. Now we want to get the y on its own, so let's take away 1 and take away 1 to get rid of this plus 1. So we'll be left with, on the right hand side, we'll be left with our 3y. We took away 1 to get rid of the plus 1, so it's just going to be 3y on its own. And then the right hand side would have 12x and then minus 1. Now we want to get y on its own, so we don't want 3 times y, so let's divide both sides by 3. So let's divide by 3 and divide by 3, or just divide everything by 3. And that would give us, on the left hand side, we'd have y, because we're dividing by 3 to get rid of the times by 3. And then, and that's the same as 1y. And on the right hand side, we'd have 12x divided by 3, that's 4x. And then we've got minus 1 divided by 3, that's going to be minus a third. Now, in this question, we were asked to show that these two lines are parallel. That means they'd have the same gradients. And as you can see, the first line, this y equals 4x minus 1, it has a gradient of 4. And also this line, whenever we rearranged it, we've got y equals 4x minus a third. And again, the gradient's equal to 4. So that also would have a gradient of 4. And then we just write that. So both lines have a gradient of 4. Okay, let's have a look at question number 22. So question number 22 says, write down the equation of the line that's parallel to 8x minus 2y equals 3 and passes through the point 5 minus 1. So whenever we're doing this, we know that the equation of the straight line that's parallel to this would be in the form y equals mx plus c. So we want to find our m and we want to find our c. So m is the gradient of the line, and because it's parallel to this line, it would have the same gradient. But unfortunately with this line, we don't have it in the form y equals mx plus c. We don't have it in this format. So we need to rearrange this to get y to be the subject to then see what the gradient would be. So let's make the y the subject. So at the minute, we've got 8x minus 2y equals 3. Now I want it to be y equals, the fact that this is minus 2y bothers me. So I'm going to add 2y to both sides. So I'm going to add 2y to the left hand side to get rid of the minus 2y. And then we'd add 2y to the right hand side. And that'll make our y's positive, which is quite handy. So on this left hand side, we had 8x minus 2y. We added 2y's to get rid of the minus 2y's, so we'd just be left with 8x on the left hand side. On the right hand side, we had 3, and we're adding 2y, so that would be 3 plus 2y. Now this is great because at least our y's are positive now because we want it in the form y equals. So now we want to get the y on its own, so we want to get rid of this 3, and then we want to get rid of this multiplied by 2. So let's get rid of this 3. So let's take away 3 from both sides of this equation. So let's minus 3 and minus 3. 8x minus 3, well, it's just going to be 8x minus 3. And on the right-hand side, we took away 3 to get rid of this 3, so we'd just be left with plus 2y, or just 2y. Now we don't want 2y, we want y on its own, so let's divide it by 2, because this is multiplied by 2, let's divide by 2. So divide by 2, the left-hand side, that's everything on the left-hand side, and divide by 2, that's the right-hand side too. So let's divide by 2, so 8x divided by 2, that's 4x. And then we've got minus 3 divided by 2, so it's going to be minus 3 over 2 or minus 1.5, depending on how you wish to write it. So it could be minus 1.5, or you could write minus 3 over 2 as a fraction. That's up to you. Actually, it's not that important because in this question we want to find the gradient of this line. So we just really want to find that, hopefully, that it's 4, and we'll see that in a second. And here we've got 2y divided by 2, and 2y divided by 2 would just be y, because we're dividing by 2 to get rid of the multiply by 2, so we'd just be left with y. So we've got y equals 4x minus 1.5, or minus 3 over 2. So we rearrange this to make y the subject so we can find the gradient of this line, and the gradient of this line is 4. So that means that the equation of the line that we're trying to find is parallel to this, so it would have the same gradient, so it's going to be y equals 4x plus c. So we now just need to find where our parallel line passes through the y-axis, that y-intercept, that plus c. And we know it passes through the point 5 minus 1. So we know it's a line with gradient 4 that passes through the point 5 minus 1. So we then just need to find that y-intercept. So I'm going to label the x-coordinate and the y-coordinate. So x would be 5 and y would be minus 1. And let's substitute those into our equation to find our c. So y, which is minus 1, equals, and then we've got 4 times x, and x is 5. 4 times 5 is 20, plus c. Now we want to get c on its own, so let's get rid of this 20. So let's take away 20 and take away 20. Minus 1, take away another 20 would bring us down to minus 21. And on the right-hand side, we took away 20 to get rid of the 20, so we just left with c. So we've got c equals minus 21. So our equation would be, well, we know it's y equals, we know it's got a gradient of 4, so it's 4x, and we know it crosses the y-axis at minus 21, so it'd be minus 21. And that's it. So the answer would be y equals 4x minus 21. Okay, let's have a look at question 23. Okay, let's have a look at question number 23. And question number 23 is our penultimate question. So line A and B are parallel, that means they'll have the same gradients. And the line A passes through the points 3, 4 and 3, 7. And the line B passes through the points 1, 0 and 10p. Now, because they're parallel, they have the same gradients. So we can work out the gradient of the line that passes through these points, and then we can use that then to work out what p would be. So let's get the gradient of the line that passes through these points. So let's do a little sketch. So let's do our x and y axis, so x axis and y axis. And we've got our points minus 3, 4, so minus 3, 4, so that'd be somewhere like that. And then we've got 3, 7, so 3 across and 7, so it's a bit higher there. We want to find the gradient of the line that goes through these 2 points. So let's do our little triangle, our little right angle triangle that joins them up. Then we've got our line and our right angle, and let's just label our points. This is the point minus 3, 4, and this point up here would be the point 3, 7. So let's find our run. So we're going from minus 3 across to 3, so that means our run would be 6 because we're going from minus 3 to 3. And in terms of our rise, we're rising from 4 up to 7, so our rise would be 3. So we've got our rise over run, so our gradient m is equal to rise over run, which would be 3 divided by 6. And 3 over 6 is the same as a half, so our gradient is equal to a half. So that means the gradient of the line A is a half. So that means the gradient of line B would also be a half because they're parallel to each other. So that means the gradient of line B is also a half, and that's going to be quite useful for us. So again, let's do another sketch. So we've got our x and y axis, and let's put our points. So we've got the point 1, 0, so that's going to be about there. We've got the point 10p, so it's going to be 10 across. Now we know the gradient's a half, so it is going upwards, so it's going to be up here somewhere. And then let's just join our points up. And we know the gradient of this line is equal to half. So let's make a little right angle triangle, and let's work out our rise and our run. So let's just label our points. So we've got 1, 0, and this point up here would be 10, and then a certain height p, which we're trying to find, that height p. In terms of our run, we're going from 1 across to 10, so that means our run would be 9. And in terms of our rise, we're going from 0 up to p. So because we're going from 0 up to p, our rise would be p. So that means that our gradient, our rise over run, is equal to a half. So let's write that down. So that the gradient, rise over run, is equal to a half. So we've got our rise over run is equal to a half. So here we've got our rise. Our rise is p, so we've got p over, and then our run, which is 9, is equal to a half. So we've got p divided by 9 is equal to a half. And we want to find what p is, so let's multiply both sides by 9, so we're just left with p. So our left-hand side, we had p divided by 9. We times by 9 to get rid of the divide by 9, so we're just going to be left with p. And then we've got a half, and we're going to multiply that by 9. Now half is 0.5. If you times that by 9, you get 4.5, or 4.5. So that means that p is equal to 4.5, or 4.5. And that's it. The question said find the value of p. P is going to be 4.5. So let's have a look at our last question. So question number 24. Question 24 says a straight line L passes through the point minus 2, 5 and is parallel to x plus 2y equals 4. Find the coordinates of where L crosses the x-axis. So in this question, we know that the line L passes through this point minus 2, 5 and is parallel to this line. Let's rearrange this and make y the subject to find its gradient, and then we'd know the gradient of the line L. So let's start off with that. So we've got x plus 2y equals 4. So we want to get y on its own. So let's minus x and minus x to then get rid of the x on the left-hand side, 2y. And on the right-hand side, we could write 4 minus x, but I'm just going to put the x at the front because whenever I write y equals mx plus c, I like having that x term first. So instead of writing 4 minus x, I'm going to write minus x, and then I'd write then plus 4 because the 4 is positive, so plus 4. So we've got 2y equals minus x plus 4. Now we want to get rid of this multiplied by 2, so let's divide by 2. So let's just divide the left-hand side by 2 and the right-hand side by 2. On the left-hand side, 2y divided by 2 would just be y. And on the right-hand side, we had minus x, which is minus 1x. We're dividing that by 2, so that would then be minus half x. And then we had plus 4, but we're dividing by 2, so it'll be plus 2. So we've got y equals minus a half x plus 2. So the gradient of this line would be minus a half. So we're trying to find, first of all, the equation of this line L, and then we'll find where it crosses the x-axis later. So let's find the equation of L first of all. So L will be in the format y equals mx plus c. And its gradient was minus a half, so it's y equals minus a half x plus c. Now we know a point it passes through, that means then we can find our plus c. We know that our x would be equal to minus 2 and our y would be equal to 5. So let's substitute those in and find our plus c. And that means then we can find the equation of the line L. Once we find this equation, we can then find out where it crosses the x-axis. So y, which is 5, equals, so then we're going to do minus a half times x, and minus a half times minus 2, well, negative times a negative is a positive, so it's positive, and a half times 2 would be 1, so it'll be 1 plus c. Let's take away 1 from both sides, so we'd then get 4 equals c. So c equals 4. So that means that our equation of the straight line L would be y equals minus a half x plus 4. So that's the equation of L. Now we want to find where that crosses the x-axis. So if it's where it crosses the x-axis, we know its height will be 0. If its height is 0, that means that y is equal to 0, the height is 0. So that means we're going to write then 0 equals minus a half x plus 4. And if we solve this to find x, we can then find where that line crosses that x-axis. So let's solve this. So let's take away 4 from both sides. So take away 4 and take away 4 would leave us with 0 take away 4 is minus 4. And on the right hand side we had minus a half x. We then took away 4 to get rid of the plus 4, so we'd just be left with minus a half x. Now we want to find out what x is, so we don't want this minus a half here, so let's then divide both sides by minus a half. So divide by minus a half and divide by minus a half. Minus 4 divided by minus a half, well, negative divided by negative is a positive, and 4 divided by half, well, whenever you divide something by half, well, you're looking at how many halves are in 4, and that would be 8. So 4 divided by half is 8, so minus 4 divided by minus a half is 8. So we'd have 8 equals, and we divided by minus a half to get rid of the multiply by minus a half, so we'd just be left with x. So x equals 8. So that means our straight line L will cross the x-axis whenever x is equal to 8. So let's just write that as a coordinate. So it's the point 8. And then we know its height is 0, so 0. So across the x-axis at the point 8, 0. So if you want to find where a line crosses the x-axis, let y equal 0. And likewise, if you want to find where something crosses the y-axis, you let x equal 0. Okay, so that's it. And that's it. So these have been the video solutions to the parallel lines practice questions. I really hope you found this video useful. If you do need any extra help on parallel lines, watch video 196 on Corbettmaths or scan this QR code. And if you have found this video useful, please like it, please subscribe to the YouTube channel, and thanks so much. Cheers. Bye.